In this experiment, we're going to be determining like how much of the total composition of a hydrated compound is actually water. A hydrate or a hydrated compound, it's a compound that contains water molecules as part of its structure. So we're going to be working with an ionic compound, which is a compound that contains ions, and ions are of opposite charges. So when you have this structure or a simplified structure of an ionic compound, it will look something like what I am showing you here, where opposite charges are attracting each other. And this is a simplified because it doesn't look like this, but this is enough for you to see what's happening with the water molecules. So when a solution containing one of these ionic compounds, when the water evaporates, you get your solid, and some of the water that you had originally as part of the solution will be trapped in the structure of your ionic compound. Those water molecules are attracted by a physical, okay? It's a physical interaction, which means that we can actually remove the water without affecting the actual structure of your ionic compound. So, like what we're doing to determine like how much of your total mass in a hydrated compound is water is simple thing. We have the hydrated compound, and we're going to add heat to that hydrated compound, and we're going to get our compound but without the water. So what is happening is that the water it's evaporating with the heat that is being added to your compound. Okay? We're increasing the temperature of the hydrated compound, and this is part of the experimental procedure. So adding heat will evaporate the water without changing the composition of your original compound. The only change that is happening is that the water molecules that you have trapped as part of the structure of your hydrated compound, the water is going to evaporate. So a couple of things that you need to know to perform your calculations here. Calculating formula weight. So the formula weight you can find in the periodic table. And the number that you have in the periodic table is in atomic mass units. But we use that number right there, the one that I highlighted in green. That number is the atomic weight, which is the same as the molar mass. And those units for molar mass are grams per mole. Mole is the unit for amount of substance in the international system of units. And grams is the unit of mass that we're going to be using in the lab. So all of the masses that we're determining as part of the experiment are going to be in grams. So you can check like your own periodic table. I'm making a drawing here to simplify things. So for hydrogen, which is your element number 1, you have a molar mass that it's 1.01, and that's a rounded number. For oxygen, you have 16. So those are just two examples. You can check the molar masses for everything in your periodic table. So when you're calculating the formula weight for a compound, such as water, which is the one that I'm using for my example here, in your formula for water, you have 2 hydrogens and 1 oxygen. Okay? That subscript right there is telling you that you have 2 hydrogens Then for oxygen, there's no number, which means that it's a 1. So you have 2 hydrogens. The mass for each hydrogen is 1.01 grams per mole. And you have 2 of them. So that 2 is that one right there. Plus your oxygen, which is just 1. For that one, I'm going to write down 16 grams per mole. Okay? So units of grams per mole. So this here, it's 2.02 grams per mole plus 16 grams per mole, which is going to give you a total of 18.2 grams per mole. Okay? So in your water molecule, 2 hydrogens, 1 oxygen, and you're going to have a molar mass that is equal to 18.02 grams per mole. Okay? So that's how we calculate the formula weight or the molar mass for a compound. A formula weight is the same thing, but we'll have like different units, okay? Not grams per mole. For formula weight, we use atomic mass units. The formula weight of a compound and the molar mass, they are numerically equal. Yeah? So you have the same magnitude of the same number, but with different units. If we're referring to the formula weight, then we have units of atomic mass units. If we're referring to the molar mass, it's the same number as your formula weight, but with units of grams per mole. So we calculated the molar mass for a water molecule, H2O, 2 hydrogens, 1 oxygen, and the molar mass is the addition of all of the masses that you have in that compound. So for water, we have 18.02. In units of molar mass, we have grams per mole. Now, to calculate the molar mass of a compound that is a little bit more complicated, like a hydrate, we have to add together not just the water, but also the mass of your compound, the ionic compound. So I'm giving you the mass, the formula for a hydrated compound, and this is just as an example. We can apply the same thing to different compounds. So we have here nickel sulfate. That's your formula. And that hydrated compound contains 7 water molecules, or 7 molecules of hydration, which is another way of saying the same thing. So to calculate the molar mass or the formula weight for this specific compound here, your nickel sulfate with 7 water molecules, we need to add together everything. Okay? So the mass of your 7 water molecules here plus the mass of your nickel sulfate, that one right there. So I calculated the masses in separate steps. Okay? I added here, this is from the periodic table, I have for nickel right there a mass of 5869, and then for sulfur I have here from the periodic table 32.06. You already have for oxygen. Okay? So I'm calculated down here the mass for your nickel sulfate, the part that I have highlighted in purple. So I have 1 nickel, that's 1 times 58.69 plus you have 1 S, so that's 1 times 32.06 plus for oxygen you have 4 of them right there in your formula, 4. So I have my 4 here, and the mass for oxygen is 16. Okay, so all of this added together is giving you 154.8, which is the mass of your nickel sulfate, just that part, the one that I have in purple. Now for the water, you have the mass of one water molecule, just one. It's 2 hydrogens, 1 oxygen. That's the 18.02 that we calculated before. but in your hydrated compound we have 7 of them. So 7 times your 18.02 is 126.1. So to calculate the total mass for your hydrated compound is the mass of your nickel sulfate, that number right there, 154.8, plus your 126.1, which is the mass for your 7 water molecules. Now adding all of those numbers together for your nickel sulfate plus the 7 water molecules that you have as part of your hydrated compound, that's 154.8 plus 126.1, and that's 280.9. And that's grams per mole. So that number represents the mass of your hydrated compound, your nickel sulfate, and the 7 water molecules that you have in that hydrated compound. So that's the total mass. So when we finish the experiment, we're going to have the mass of your hydrated compound. That's your first data point. Then we're going to have the mass of your compound after heating it up, which means that we're evaporating the water. So we can calculate how much water was in your initial hydrated, and we can use the mass of the water and the mass of your hydrated compound to calculate the percent of water in your hydrated compound. Percent by mass of water, it's going to be given by a mathematical equation. So we have the mass of the water divided by the total mass of compound times 100, because it's a percentage. So I calculated the molar mass of my hydrated compound in 2 separate steps. I have the mass of your nickel sulfate highlighted in purple, my 154.8, plus the mass of your 7 molecules of water, which is your 126.1. If you do it in this way, you have the mass of the water that you need in your equation to calculate the percentage, and you have the total mass of the compound, so you don't have to go back to calculate the mass of the water. So I have that the mass of the water is 126.1 grams per mole over the total, which is 280.9 grams per mole times 100. Since both numbers are in units of grams per mole, your units are going to cancel out. So 126.1 divided by 280.9 times 100, that's rounded to 2 significant figures, I'm going to get 45%, and something close to 45%. It means that in your nickel sulfate, in that hydrated compound with your 7 water molecules, out of the total mass of your compound, 45% of that mass comes from the water molecules that you have in that compound. So now let's check your... So part 1 is how to use the Bunsen burner, which is something that I will demonstrate in class. Now, part two is where you actually start preparing your sample to get your final results. So the first thing that you're going to do is that you're going to find your crucible, and you're going to use a paper towel to clean your crucible. Okay? Now you have to prepare your setup. You can look at the one that is going to be prepared for you in the lab, or you can look at your picture in your lab manual in page 62. Important thing is that in your setup, your Bunsen burner and the crucible, you need to have 3 inches in between them. It's a more or less, it's an approximation. So I will be walking around to check that everyone has like a proper distance between the flame and the crucible. So first thing that you're doing is you're cleaning your crucible with a damp paper towel, but then you're going to clean your crucible using heat. Okay? So you're going to set up your Bunsen burner and your crucible, and you're going to heat your crucible for 3 minutes. Okay? When you're heating your crucible, what we're doing is removing any moisture or any impurities that you have in the crucible. You have to remember, like, all equipment or every piece of glassware that you're using in the lab, they look exactly the same if they are at room temperature or if they're hot. So you're using an open flame to heat up your crucible, and you have to assume that everything is hot. So you have to be extremely careful. You're not touching your crucible with your hands after you clean your crucible with your damp paper towel. After that point, even if the crucible is at room temperature, you're not touching it with your hands. You have equipment to move your crucible around. You're going to have a tongs. You can use paper towel. You have a wire gauze that you can use to put your crucible on top of that one, but you're using the tongs to move your crucible around in the classroom. So you're heating up your crucible for 3 minutes, and that's the cleaning part. So you're going to remove the crucible from the Bunsen burner using the tongs, and you're going to put your crucible on top of your wire gauze. Okay? So you're not placing your crucible on top of paper towel. You're going to burn the paper towel. On top of the bench, you're going to burn the bench. So the crucible goes on top of your wire gauze that you have available just for that. So you're waiting for your crucible to cool down until it's about at room temperature. So I will show you how you're going to determine if your crucible is cool or if it's still hot. But you have to be patient. So while that crucible is cooling down, since you have your Bunsen burner on, you can place the second crucible and you can start cleaning that one. So you're waiting for your crucible to cool down, and after it's at room temperature, you can take your crucible with you and you can determine the mass of that crucible using the mass balance. So you're going to copy the mass of your crucible with all of the decimal places that the mass balance is telling you. So I don't want to see in your lab manual that the mass of the crucible is 31. If the mass of the crucible is 31, the mass balance is telling you that the mass of the crucible is 31.000, and you should have all 3 decimal places as part of your number. So you're heating up the second crucible. Your partner can stay looking at the crucible that it's heating up just to clean, right, for 3 minutes while you're determining the mass of the first one, or you can wait for both of them to be at room temperature, and then you can go to the same mass balance to determine the mass of both of them. So you have your 2 crucibles that are clean, and you have the mass, and you're copying the mass in your lab manual. You have your numbers in your lab manual, and now you can go back to your bench you are going to find your hydrated compound. It's in a vial. What you have in that vial should be enough for your 2 samples. So you're going to take the vial with you and your clean crucibles that you have the mass of them when they were empty. You're going to go to the mass balance. You have your crucible. You're going to put your crucible on the mass balance. You have the mass of the empty crucible, okay, that you have in your lab manual. Now, to your crucible, you're going to use a spatula and you're going to add small amounts of your solid, your hydrated compound, until the original mass of your empty crucible increases by about 2 grams. Okay, so you have your crucible, empty crucible on your mass balance. And let's say that the mass of your empty crucible is 60.000 grams. So you're going to start adding your hydrated compound inside of your crucible until the mass is close to 62.000. You need 2 grams of hydrate. So you're going to add about 2 grams in your empty crucible. And what I mean with about 2 grams is that you don't need to have exactly 2 grams. You see my example in the paper, you're adding solid until the mass increases to 61.850. Okay? Or 62.051. Those are examples. So you see 61.850 is not exactly 2 grams. That will be the empty is 60, and now you're adding mass of the solid until it goes to 61.850, which means that the difference between the mass of the crucible with your solid in minus the mass of your empty crucible, that will give you 1.850. It's something close to 2, not exactly 2. You're aiming for 2 grams, but if you have a little bit less or a little bit more, that is okay. As long as you copy exactly how much you have, everything should work fine. So those are examples. You can go to 62.051. So you have more than 2 grams, but it's a small amount, okay, above your 2 grams. So that's perfectly fine. Just make sure that you have the correct mass for the empty crucible and that you're adding about 2 grams of your solid and that you're copying exactly how much you have in the crucible. It's not that you're adding about 2 grams and then you're going to assume that you have exactly 2 grams. You need to copy exactly how much you have, the mass of the crucible with the solid inside. Now that you have your crucibles with the solid inside, you can go back to your bench. You're going to turn on the Bunsen burner again because your Bunsen burners, they cannot stay on if you're not in front of them. So you're turning on your Bunsen burner and using the tongs all the time to move your crucibles around. You're going to put the first crucible and make sure that you know which one is which. You have 2 samples, so you have to keep track of which sample you're doing at every single moment. Okay? You cannot mix them up because you will get the wrong percentages at the end. Also, you have to use the same mass balance for everything. If you're using a mass balance for your empty crucible, you're going to use the same one to determine how much hydrate you're adding into the crucible. And you're going to use the same one to determine the mass of your crucible after you're heating it up. Okay? So same mass balance along the experiment, okay? So everything on the same one. So you're going to start evaporating your hydrate. You see on your lab manual, it says to use the lid. I'm not using the lid at all. You don't have to, okay? Just do everything as I'm telling you on this part here, no lids. So you're going to put your crucible and you're going to set up your flame, okay, as I'm going to explain in the lab. You're going to set up your flame to have a gentle flame in the beginning that will help some of the water to evaporate, and it's going to avoid like from your sample to splatter out of your crucible. If it's heat up too quickly, that can happen. So to avoid for that to happen, we're heating up the sample gently for 5 minutes. So you have your sample and you're heating it up for 5 minutes, time it with a gentle flame. We're not turning off the Bunsen burner. We're not removing the crucible from the Bunsen burner. With the crucible right where it is, now you're going to adjust the flame to have an intense flame. And you're going to continue heating your sample for another 10 minutes, okay? So you're heating your sample 5 minutes gently, and then you're going to adjust the flame to heat up your sample for another 10 minutes using an intense flame. So it's 15 minutes in total, 5 with the gentle and then 10 with an intense flame. Now, after your 15 minutes, we're going to turn off the crucible, the Bunsen burner. We're going to remove the crucible using the tongs, and we're going to place the crucible on top of your wire gauze, and you're going to let it cool down to room temperature. Once your crucible is at room temperature, you can walk to the mass balance and you can determine the mass of your crucible with the solid inside, right? So you had in the beginning your hydrated compound, and what you have now in your crucible, it's the compound, but we're already removing the water because it was heated up, okay? So you're determining the mass of your crucible with the solid inside, and that's the mass after the first heating. A total of 15 minutes, that's your first heating. 5 minutes with a gentle flame, 10 minutes with an intense flame. So you have to copy your number in your lab book, in your data sheet, and you have like where to put the mass of your crucible with the solid after the first heating. You're going to walk back to your station and you're going to put the crucible back again for another 5 minutes and intense flame since the beginning. Okay? So another 5 minutes with intense flame. You're going to turn off the Bunsen burner, remove the crucible from the flame, put it in a wire gauze, let it cool down to room temperature, and then go back to the mass balance and determine the mass of your crucible with the solid inside. You should check your two numbers. Okay? The mass after the first heating and the mass after the second heating. Your numbers should be about the same. So before you continue, you should show me your numbers and ask me to check if your numbers are correct, if they're good enough, or if you have to go back and heat your sample again. So if the masses of your first heating and the second heating are close to each other, after I check them, you're done with your sample. You have your two numbers to perform all of your calculations. Now you have to repeat everything with your second sample. Okay? So you clean two crucibles, you have the mass of your two empty crucibles, you added the solid to your two crucibles, your hydrated compound. So you remove the water from one, first heating, second heating, and now you can do the same with the second one. Okay?